We've seen how to build horizontal and vertical lists in this tutorial. Sometimes, your app might instead need a grid layout with rows and columns of content. That'll be the main topic for this video, creating the UI for a grid style list. This is going to be the third tab of our app that will contain the search feature. Therefore, we'll need to create a new file, press Command N, SwiftUI View, next, search, view, create, make some room after line 10. We'll define an array of titles here that will populate the list. Var titles equals title dot preview titles. For now, our sample data works great. Go ahead and delete the famous hello world. Instead, type scroll view with braces. This screen will later return a list of titles from a search. Therefore, we want to scroll view in case the search results exceed the screen capacity. Inside the scroll view, type lazy vgrid, down arrow and right arrow to see more options. Select the option with columns and content. Lazy vgrid allows the items to stack vertically into columns. Lazy means this grid will load elements only when they are needed on screen. Columns is an array of grid items that define how many columns our grid has. For this grid, 3 is perfect, meaning we need to add 3 grid items. Select grid item, press enter, add a set of parentheses before the closing brace, comma, grid item, parentheses, comma, grid item, parentheses. We could have defined different spacings and other properties for the grid items. However, just a simple version is good for our needs. Tab over to content, press enter to complete the closure. The content of our lazy vgrid can go inside these braces. For each, open parentheses, titles, close parentheses, bracket, title in, enter twice. This loops through our titles list and gives us access to each element. For each element, just the movie poster is good. Put your cursor inside the for each braces, async image, URL, parentheses string, title, dot poster path, question mark, quotes. We convert the poster path string into a URL and also safely unwrap it. If it's nil, an empty string is passed. A placeholder is needed for our async image as it loads. Add an open brace at the end. Image in. Press enter a couple times. After the closing brace, placeholder, enter, progress view. This shows a progress circle while the image loads. Now we can add modifiers to our async image. Inside the braces, image, enter, dot resizable, dot scale to fit, dot clip shape, dot rect, parentheses corner radius, 10. These modifiers allow the image to resize into the allowed space while keeping good aspect ratio and rounding the corners. To finish this off, we can add a frame for each of the images. Select the closing placeholder brace, enter, dot frame, select the one with width and height. Width will be 120 points and height will be 200 points. This allows the images to only be within this frame. Our lazy vgrid is complete. We can scroll down on the list if more elements get populated. It's a shame our sample data only has 3 titles, so we can't see how the next row looks like. Don't worry, real data will populate here soon. We can run a quick test. Open up Content View. Delete the text inside the Search tab. Search View. Make sure your API config has the movie database key. Command R to run. Our simulator is up and running. Click on the search tab. We have the grid showing. That wraps up this video. Thank you so much for watching. There's a good chance you'll need a toolbar at some point in your app. It's perfect for storing buttons, setting a title, or even housing a search bar. In this video, we'll build a SwiftUI toolbar and add simple logic to make it dynamic. We can start by adding a title first. For this feature, the main view needs to be inside a navigation stack. Inside Search View, right-click on Scroll View, Embed, Navigation, Stack. This is a great first step, as we'll need navigation later for this view. The rule of thumb when adding a navigation title is to be as close to the navigation stack as possible. The closest we can get is after our scroll view. Find the scroll view closing brace. I'll scroll down, press enter after the brace, navigation title. It's tempting to hardcode the title in there. However, a good habit is to have the strings in one place where we can manage them better. It'll also make adding logic easier. Open constants.swift. Make some space after the top rated TV string. Static let movie search string equals quotes movie search. Make a new line. Static let TV search string equals quotes TV search. In our view, we'll be able to search for either a movie or TV show. Therefore, we want the title to change depending on what's selected. In addition, we'll also need two icons. Scroll down, hit enter after the download icon string, static let TV icon string equals quotes, copy, and paste it below. Change the second TV to movie. Click inside the TV icon string quotes. The SF symbol name goes inside here. I happen to know the name is just TV. Select inside the movie icon string quotes. Command Shift L. The icon for movies is going to be the clapper that says we'll take their in. Search for clapper. Press enter, and the SF symbol name gets filled out. A good trick if you ever need to search for SF symbols. Our strings and icons are ready. Go back to searchview.swift. Inside navigation title, put constants.movie search string. The title looks good. We also need a button to toggle between a movie and TV search. Press enter after navigation title, toolbar with braces. I'll scroll down. Inside the braces, we can define a toolbar item. Select the one that has placement and content. Placement is where the toolbar item will be. Top bar trailing. This puts the item on the right of the bar. Tab over to content and press enter. Inside these braces, we can define what's in the toolbar. Type button with braces. After the closing brace, label. Press enter to autocomplete. Label lets us define how the button looks. In this case, the button will be an SF symbol. Type image, system name, constants.movie icon string. Nice. We get the image on the top right. Our toolbar is looking good. We just need to add some logic. When the movie icon is tapped, the title and icon should switch to TV. For this, a new variable is needed. Scroll up. Make a new line after var titles. at state private var search by movies equals true. At state allows the UI to change its variable. Private allows only this view to access the variable. Private isn't absolutely needed here, but it's good practice to keep everything scoped to what they need. With our new boolean, we can scroll down to the toolbar item. Inside button, type search by movies dot toggle. Now when the button is pressed, search by movies will go from true to false and vice versa. To finish the logic, we need both the navigation title and icon to depend on our boolean. Before constants.movie search string inside title, search by movies, question mark, after constants.movie search string, colon, constants.tv search string. We use a ternary operator where if search by movies is true, then show the movie search string. If it's false, then show the TV search string for the navigation title. Copy the ternary operator logic, paste it as the system name variable. Just use movie icon string and TV icon string. This completes the logic. We can test this inside our preview. Nice. Everything is in working order. This is a great place to stop. Our UI has an awesome toolbar and some logic to help in the later stages. Thank you for watching. I'll see you in the next one. Search bars are a common feature in iOS apps. They can help filter and organize data for the user. In this video, we'll add a search bar to our UI and construct the API search URL. To start off, we'll need new string constants for our search bar prompt text. This text will be displayed when the bar is empty. Open constants. Make a new line after TV search string. Static let movie placeholder string equals quotes search for a movie. Copy and paste the line we just made. Switch out movie for TV. Search for a TV show. We'll need these two since we'll be switching between a movie search and TV search. Go back to search view. In addition to these new strings, we also need a variable to hold what the user searches. Make some space after line 12. At state private var search text equals quotes. At state allows the view to modify the variable. We use private because no other file will need to access this variable directly. All the precursors are ready. Scroll down and find the toolbar closing brace. Enter dot searchable. Choose the one with text and prompt. For text, we can put $search text. This creates a binding. Whatever the user types in the search bar gets synced into our search text variable. Tab over to prompt, search by movies, question mark, constants, dot movie placeholder string, colon, constants, dot TV placeholder string. We see the ternary operator here, allowing us to display the correct prompt depending on the type of search. Please update your API keys in api-config.json. Press Command R to run. Our app is up. Navigate to the search tab. Nice. Our search bar is showing. We can toggle it back and forth. everything is working correctly. I do want to point out how easy it was to add the search bar thanks to SwiftUI. In addition, we were able to use .searchable because our view is inside a navigation stack. If we didn't use a navigation stack, for example, if we were in a sheet, then we would have to make the bar manually, which isn't too bad. We can get the ball rolling on hooking up the search bar to our API. A good place to start is to build the URL. Open Data Fetcher. I'll paste what a search call looks like. This one is a bit different than the rest of the URLs we've built so far. The word search is before the media type, and there are two queries: the API key and the movie or TV show we are searching. In this example, it's the movie Pulp Fiction. With this accounted for, we can scroll down to our build URL function. Click after the else if closing brace. Hit enter a couple times. Add else if type double equals quotes search with braces. Copy the path from the first else if statement. Paste it inside our second else if. Switch around type and media. I'll backspace else so it chains correctly. Admittedly, these chaining if statements aren't the prettiest. It would probably look better with a switch case statement. Maybe we'll go back and tighten up our code in a future video. To wrap up, we just need to handle our second query item for the search URL. In the arguments, add a comma after type, search, phrase, :string, question mark, equals nil. This argument is optional with a default value of nil, allowing the function to be used without a search phrase. Scroll down before we make the URL. Make some room before the guardlet statement. Bar URL query items equals brackets. Copy the API key query item and paste it inside our new array. Every API call needs this API key query item to work. Now we can add the second item only if search phrase isn't nil. Make some space, if flat, search phrase with braces, URL query items that append URL query item, name and value. Name will be quotes query. Value will be search phrase. Now we can pass the new URL query items in our URL. This successfully puts the search query into our URL only if it's needed. Unfortunately, we can't see the search URL in action just yet, but we are getting closer to adding the feature. We'll continue the next video. Thank you for watching. ViewModels in SwiftUI are surprisingly controversial. That's because SwiftUI was designed with state management baked right into the view. In my experience, as the app grows and networking calls come into play, ViewModels can help manage responses and keep the UI focused. We already have a ViewModel in our current app. However, this ViewModel is working with the home, title detail, and upcoming screens. To keep things better organized, we can make a new one to just focus on the search screen. Hit Command N, Swift file, next, search, view, model. Great. Like our first view model, this one also needs to observe changes to its properties and communicate them. To do this, we can type @observable class search view model with braces. We're using a class here because it's a reference type, meaning changes to its properties reflect everywhere it's used. We've used enums to keep track of the different fetching states so far in the course. For this view model, we'll keep it simple and start with an optional property in case an error occurs. Private set var error message :string ? Private set allows only this file to set the value of error string while still allowing others to read it. We'll also need an array of titles to store the results. Private set var search titles :title equals empty brackets. Making the array empty ensures it's ready to use and won't need to be unwrapped later if something fails. The last property we need is an instance of our data fetcher to make the API calls. Private let data fetcher equals data fetcher. It's completely private here as no other file will need access to it. Let is also used because it won't change. Our properties are ready. We can now make our function. Func get search titles by media :string for title :string async with braces. Media will change depending if you are in a TV search or movie search. Title is a search term the user will enter in the search bar. Async is used as this function will be making a network call. Inside our function, write a do catch block. Let's go reverse and fill out the catch block first. Print error message equals error dot localize description. This prints the error to our log and assigns a user-friendly message to our error message. We'll display the error message in our UI later. Inside the do block, error message equals nil. If title is empty, search titles equals try awaits data fetcher dot fetch titles for media by trending. We first clear out any error messages. Title is going to be what the user types into the search bar. If the search bar is empty, we'll return a trending list of movies or TV shows, depending on what the user is searching. After the if statement, type else with braces. Before we can fill out this else statement, we do need to make an adjustment. Open data fetcher. Currently, our fetch titles function doesn't have a way to add a search term. We can fix this by adding another parameter. After string, add a comma with title :string ? Equals nil. This creates an optional parameter called title and assigns nil if it's not used. Title will be how we pass our search term. With our new parameter, we just need to adjust the build URL call. Add a comma after type, search phrase :title. Our build URL function was made to complete the search URL only if search phrase is not nil. With this adjustment, go back to search view model. Inside the else block, search titles equals try awaits data fetcher dot fetch titles for by width. For will be the media passed in the arguments. We can pass search in for by. Width will be title. In hindsight, it would probably be better to group our parameters with enums. If we were working with a team, they most likely wouldn't know to pass in the string search or trending for the different API calls. Just some feedback for our own code. This completes our search view model. All that's left is to wire it up to the UI. We'll tackle this in the next video. Thank you for watching. Delaying an API call or debouncing is a great way to build an efficient search feature. Using this method can help prevent unnecessary requests every time the user types. In this video, we'll demonstrate how to complete an async search bar using debouncing. With our view model ready, we can now hook it up to our view. Open search view. Make a new line after search text. Private flat search view model equals search view model. This view model will hold our titles and error if there is one. Let's complete the search bar logic first. Scroll down. After .searchable, add .task. Select the one with ID and action. For ID, add search text. Tab. Press enter to complete the closure. This task modifier will rerun the task inside anytime search text changes. Search text is bound to the search bar. Therefore, anytime the user types, a new API search will trigger. Inside the code block, type try $await task.sleep 4.milliseconds 500. This adds half a second delay after the user stops typing. Without the delay, our API will get called after every keystroke, which isn't ideal. Make some space. If task.isCancelled, return. Here, we exit early if the task was cancelled to avoid running outdated searches. That can happen if the user keeps typing after stopping, causing the text to change mid-task. Now we can add our API call. Await search view model dot get search titles by search by movies movie TV for search text. We use await because the function is asynchronous, meaning it runs in the background. The call will look for either a movie or TV show, depending on the mode, with the search text. This completes our search bar logic. We also need to add the API call when toggling between a movie or TV search. Highlight and copy line 51. Scroll up to the trailing toolbar icon. Add a task block after toggling the boolean. Paste the API call in it. The task block allows us to call an asynchronous function inside a place that usually doesn't support await. In our case, inside a button tab. Just a couple of more things before we can test. Scroll up. Delete the titles inside for each. Replace instead with search view model dot search titles. We can use these titles as they will get populated with our API calls. Don't forget to delete the titles property as our sample data is no longer needed. The last thing is to display our error if one happens. The best place to have this error is right before our lazy V grid inside the scroll view. Add a couple lines before then. If let error equals search view model dot error message inside the braces text error dot foreground style dot red dot padding dot background dot ultra thin material dot clip shape dot rect corner radius 10. We added some styling to our error text. If let is great here, as if no error exists, the view will get drawn like normal. That completes this view, and we're ready to test. Please update your API keys inside API config.json and hit Command R. Our app is up and running. Click on the search tab. Nice. Our GridView populates with default titles. I'll try to search Harry Potter. Good stuff. Let's cancel. And some default movies pop back up. Toggle for a TV show. Harry Potter. Now returns TV shows. I'll search instead for one of my favorite TV shows, Breaking Bad. There it is. I do want to show how the error looks like. Off screen, I'll delete the movie database API key and run the app again. The app is back up with no API key, and we have an error on the Home tab. We didn't style this error, and it shows. Navigating to search, the error looks much better here. It scrolls up and down with our view. I do want to talk about some ways this screen can improve to wrap up. If we search for something that doesn't give results, an error saying no search results would be nice. In addition, a default image when the titles don't load would be better. Right now, we just have a progress circle that doesn't stop spinning when this happens. We won't be adding these features, but if you want to try, please feel free. Navigation is all that's left to finish this section, and that will be the topic of the next video. Thank you for watching. Our search screen is looking great, but still needs navigation to be complete. We've seen how to use both navigation path and navigation link to complete this. Out of the two, let's use navigation path for this screen. Navigation links are easier, but come with performance issues. If you're just joining us, the starter code for this video is in the description. Let's start in Search View. Make a new line after Search View model. At state private var navigation path equals navigation path. This variable will allow the view to track and control navigation history. Inside navigation stack, add parentheses, path, $, navigation path. This binds the stack's navigation state to our navigation path, letting us push and display views. Scrolling down, we need to append a title to our navigation path when it's clicked. One way is to add a tab gesture to our async image. Make a new line after .frame, .on tab gesture, navigation path, .append title. We just need to tell the path where to go when there's a title object. Scrolling further down, make a new line after .task, .navigation destination or destination. In for, type title.self, tab, press enter to complete the closure. The closure variable can be title, inside the braces, title detail view, title. When the title struct is passed into our navigation path, the view will navigate to title detail view, passing in the tab title. We're ready to run. Please update your API keys for the movie database and the YouTube API inside API config.json. Press Command R to run. Our app is running. Navigate to search. Click on the title. Perfect. Our title detail screen is working. This completes the search screen. To wrap up, I would like to add a button to the title detail screen for the final section. Open title detail view. Make some room after title overview. Button with braces. Label. Inside label text. Constants.downloadString.ghost button. We'll just keep the same button style already made earlier. I do want the button to be in the middle of the screen. Before the button, type hstack with braces. Put 2 spacers. Cut the button and paste it in between. This will center the button. Press Command R to run. The app is running. Click on any title. and our button is showing correctly. This completes our async search bar. We've come a long way with this app, and I want to thank you all for the support throughout this journey. I'll see you in the final section, Swift Data.